My YouTube channel. I am Shlok Kulkarni, and today we are going to continue with the sums of convergency chapter from Oxford General Navigation. Previously we did first three sums. Today we are going to do the next sums. So let's begin with question number 4. The great circle track from A to B measures 227 at A and 225 at B. What is the convergency of the meridians through A and B, and in which hemisphere are they? So first, very simple solution. Let's plot this. Let's say they are in the... Now here we don't know what hemisphere they are. Okay. Now here we have been given great circle at A equals to 227 and great circle of B equals to 225. The definition of convergency is the angle between two meridians, right? And the second definition of convergency is the angle between or the difference between two great circle tracks. Here great circle track at A. So whenever in exam they give a question like this, the great circle track at A is 227, great circle track at B is 225. So just A, instead of giving A to B, B to C like that, just the great circle track at A is something and great circle track at B is something. We have to write it like this, and the difference between these values will be the convergency. So here the convergency will be equal to how many degrees? 2 degrees. 227 minus 225 degree is 2 degree. So this is the part 1 of the answer. What is convergency? So it is 2 degree. Okay, it is 2 degree. Next part of the answer is in which hemisphere are they? Now great circle at A is 227. Great circle at B is 225. So that means, let's say we are in the northern hemisphere for the sake of this example, A to B. Okay, we are in the northern hemisphere for example, and let's say great circle at A, we want to go from A to B. Okay, great circle at A is, let's say, just for the sake of this illustration, 227 is 2 to 7. When it goes to destination B, that becomes when it goes to destination B becomes 2 to 5. Okay, great circle, rhumb line is a line of constant direction, but great circle is not a line of constant direction. It keeps on changing angle. So when it lands at destination B, its direction changes to a new direction of 2 to 5. Okay, now let's say we land at point B and we want to come back at point A. After refueling your aircraft, taking new passengers, we want to come back at A. So great circle going back to A will be what? The reciprocal. It will be the great circle going back to A will be the reciprocal of great circle at point B. So when coming towards B, your great circle was 2 to 5. Now going back from B to A, the great circle will be the opposite of 2 to 5. So what is the opposite of reciprocal of 2 to 5? Any value more than 180. Okay, we subtract 180 from that to get a reciprocal. So 2 to 5 minus 180 is how much? 045 degree. So to go back, it is 045 degree. So now to find hemisphere, there are step 1 is find the reciprocal direction. Find the reciprocal direction at destination. At destination. In this case, what was the reciprocal direction? It is, while coming back from B to A, it has been it has become 045 degree. That is a reciprocal direction. Step 2 is calculate the difference between great circle at A and great reciprocal direction. Great circle starting from A and the direction when coming back to A. That is the reciprocal direction. Reciprocal direction when coming back B to A, from B to A. Okay. So what is the difference? Let's calculate the difference. Great circle at A minus great circle from B to A. Great circle B to A, which is equal to great circle at A is 227. Great circle B to A is 045. That is equal to, so 227 minus 045 will be 182. 182 degree. Step 3 is a final answer. Step 3 says the difference between great circle at A and B to A is more than 180 degrees, then the hemisphere is north hemisphere. Hemisphere is north hemisphere. Okay. If the difference is more than 180 degree between great circle at A and great circle coming back B to A, then your hemisphere will be northern hemisphere. If the difference is less than 180, any value less than 180, it will be southern hemisphere. And if the value is equal to 180, that means both points are at equator, neither north nor southern hemisphere at equator. So this is the answer to your question number 4. So first we found the convergency between great circle A and B, convergency 2 degree. Then we found following 3 steps, find the reciprocal direction, subtract it, and then check whether it is 180, more than it or less than it. Question 5. Question 5. What latitude is the convergency between two meridians equal to twice the convergency at 20 degree north latitude? So here we have been given two latitudes. So let's take the latitude that we have to find out, or the unknown latitude x value. So convergency latitude x equals to d long formula into sine of latitude, which is equal to d long into sine of x. Next latitude that is given to us is 20 degree north. So convergency at latitude 20 degree equals to d long into sine 20. Okay, so instead of latitude I have put value 20 degree. So this is your step 1, writing your formulae. Let's go back to step 2, that it is given the latitude x, convergency of latitude x is twice the convergency at latitude 20 degree. So let's put that mathematically. So convergency at latitude x equals to twice the convergency at latitude what? 20 degree north. Let's open the brackets. What is convergency x equal to? D long into sine x equals to 2 into convergency at 20 degree latitude is d long into sine 20. So now what is common on both sides? That will get cancelled. D long cancel. So followed by sine of x equals to 2 into sine of 20, which is equal to 2 into sine 20 is 0.68 something. So sine of x is equal to 0.68. So x is equal to sine of inverse. This sine will go this side. So sine of inverse 0.68. So using your scientific calculator, press the top left shift button, then press sine button. You will get sine inverse. Put 0.68 there. So answer is 42.8 or approximately 43° north latitude. So our answer is 43° north latitude. So x is 43° north latitude. That means the latitude at which the convergency, okay, at 20° north. So the latitude at which the latitude at which the convergency of latitude 20° north and twice of it, that latitude is 20° north latitude. So the 20° north latitude convergency is something. At 43° north latitude, the convergency will be twice at that. So at 43° north latitude, the convergency will be twice of the convergency existing at latitude 20°. That is your answer to part 1, 43° north latitude. Now part 2. Is there a latitude where the convergency would be 3 times that the value of 20° north? 3 times. So instead of solving the whole sum, I will just write, right now I will just write this part. Okay. So let's check that. So sine of x is equal to 3 times sine of 20, which is equal to, that will give me 3 times sine 20 will give me 1 point something something. So x will be sine of inverse 1.02. Therefore x latitude will be sine of inverse 1.02 will. So in that case we get a math error written on the calculator. That means this possibility is not at all there. So there cannot be a latitude. So there cannot be a latitude. There cannot be a latitude at which where the convergency will be thrice of that existing at latitude 20°. So that is not possible. It can be twice of 20°, but it cannot be thrice of 20°. Okay. So this is how you do. Just write the simple formulae. Step 2, substitute the values. Use calculator. Okay. And then do the sum. Let's go to question number 6. Points A and B are in the same hemisphere. The initial great circle track from B to A is 268. B to A is 268 and grade from A to B is 09 or 2. In which hemisphere are A and B located? What is the rumline track from A to B? Okay. What is the rumline track from A to B? So to find hemisphere, B to A is 268 and A to B is 09 or 2. So 92 plus 1. So now let's take great circle from B to A. Now this is the kind of sum that we have done just now previously, where we were given great circle track at A and we were given great circle track at B. Okay, so great circle track at A and great circle track at B. This is what we were given. Then step 2 was to find the great circle track of B, reciprocal of great circle track of B, and you want to come from B to A. Okay. Now here we have been given the other way around. We have been given B to A or great circle track at B to be equal to 268, and we have been given the reciprocal of A to B to be equal to 092, directly. So what they have given here is they have directly given us the reciprocal. Here we used to find out reciprocal, right? So they have directly given us the reciprocal. So now we will go reverse. Now they have given the reciprocal. So now we will again find the reciprocal of this reciprocal in order to find great circle at B. We have great circle B to A or great circle at B, that is no problem. But when we start from B to A, let's say. So great circle at B is given. Then again we have to find out great circle at B initially is 268, let's say. Now when we start from B and when we come towards A, land at A, since great circle direction changes time to time, unlike rhumb line, when we land at A, this 268 will change to some other value. This great circle at A will be some other value. Okay, this other value was given to us in the previous sum. And to come back, after refilling, to come back from A to B, we had to find a reciprocal direction because we are going now in reverse direction. Now in this sum, they have given us the reciprocal direction directly, but they have not given this great circle at A, which will be something new direction different from great circle of B due to change in great circle direction. So great circle at B, just the B will be 092 plus 180 because it is less than 180. So that will give me 272 value. Now I have told you that the difference between great circle at B, this is great circle at A. Now the difference between great circle at B and great circle at A is your convergency by definition. It can be either the angle between two meridians or it can be the difference between two great circle tracks. So at B and A, the difference is your convergency. So at great circle at B is how much? Great circle at B is, so if you can see, great circle at B is 268. Great circle at A is 272. So we can either write it other way around, 272 minus 268. So convergency is 4 degree. Convergency is 4 degree. Okay. Now let's take a new slide. Convergency is 4 degree. Convergency angle will be 2 degree. Now let's plot the diagram. Now in which hemisphere are A and B? Now look at this. Great circle at B is how much? Great circle at A is how much? So it is 272, 260, sorry. At B it is 268. At B it is 68 and here it is 270. Okay, 272. So great circle at A, and coming back from great circle at A to B, it was how much? 092. So the difference to find hemisphere, the difference between great circle at B and great circle A to B is equal to how much? 268 minus 092, which is equal to 176. So if the difference is less than 176, is less than 180, so the hemisphere that you will be in is south hemisphere. So difference more than 180, north hemisphere, less than 180 south. At 180 at equal to 180, you are located at equator. So the hemisphere will be the south hemisphere. Now what is the Rumline track from A to B? Let's do it here itself. B to A, so we are in the south hemisphere, so we have this great circle, we have this Rumline. So B is here, A is here. B to A, your great circle was 268. A to B it was 092. Rumline from A to B. Very simple. What is a convergency angle? It is 2 degree. Over here we have found. Convergency was 4 degree and therefore convergency angle will be 2 degree. So convergency angle is the angle between a great circle and a Rumline. Between a great circle and a Rumline. So now great circle at A is 092. Therefore great circle at Rumline at A will be the entire great circle track minus this conversion angle. So Rumline at A to B will be great circle from at A minus convergency angle. So great circle at A is 092, convergency angle is 2. So it will be 090 degree. So that means Rumline A to B is 090. Okay, so that is easterly direction. So that means both points A and B or locations A and B are located at same latitude. Okay, so this is how you do it. Okay, so this part was not needed for this sum. Directly you could have just calculated the difference between great circle at B, which was given to you, and A to B, and you would have gotten the answer southern hemisphere. But I taught you this extra part so that if there are other sums that require this, you know what to do. Okay, so great circle A to B was given. Only to find great circle at A, we found the reciprocal of that. Similar to this, over here B was given to us, just the B, and to come back reverse, we found the reciprocal of that, and then we did that sum. So with the help of this, we found great circle at A 272, and that was useful, still useful here to find convergency. So it is important for this sum, because without that convergency, you could not have found Rumline, because with convergency only you get convergency angle. Let's go to next question. Charlie and Delta are in the same hemisphere. Great circle track from Charlie to Delta is 063 and Rumline track from Delta to Charlie is 240. In which hemisphere are they located and what is the great circle track? So here we don't have another great circle track information. So let's draw two scenarios. One where north hemisphere is there, another where south is there. So let's say in one scenario, if we are in the north, the great circle will pass like this. If we are in the south, it will pass like this from the south. Now C and D points are given. Okay. Now D to C is 240. We'll just make a little bit correction here. and over here. Rhumb line B to C is 40. So this will be your north direction, let's say south direction, west direction. So 240 is a southwesterly direction. That's why I pointed this B to C rhumb line towards the southwesterly direction. Now let's draw this diagram like normal correction like this. This is 7. Next part is great circle from Charlie to Delta is 063. This is your great circle. So 063. Charlie to Delta. This will be in this case. This bigger angle will be your 063. Over here the small angle was 063. Here the bigger angle. And what is the rhumb line given to us? Delta to Charlie 240. So over here the small angle is 240. Over here the big angle will be 240. So now this is your rhumb line. Now over here in both cases rhumb line at D to C is 240. So rhumb line from Charlie to Delta, if we want to go reverse, D to C was 240, C to D will be reciprocal of 240, which is 240 minus 180, which is 060. Same here, rhumb line from D to C 240, rhumb line from C to D will be 060. Okay, got it? So 060. So let's try and plot it here. Now look at this carefully. C to rhumb line from C to D is what? 060. So C to D 060. C to D just up to here 060. Now look at this diagram. 063 is up to this great circle. Now when you go more right hand side, as you go right hand side, your direction should increase. When you go more and more clockwise or more on more right hand side, your direction should increase. So 063 is up to here. Now this rhumb line in this diagram is an extra this angle, which is your convergency angle. This is extra. Up to here it was equal to great circle. Now this extra part right hand side is your convergency angle, which makes your rhumb line. So that great circle plus convergency angle has total made your rhumb line of 060. Now when you go right hand side, your direction should increase. But so is 060 more than 063? No. So direction has actually decreased. So over here the direction has decreased. That means the rule is not followed. So the chances are northern hemisphere is not the correct hemisphere that we are looking for. Now let's go to the southern hemisphere. In the southern hemisphere, what do we see? Great circle was the bigger angle 063 and rhumb line was the smaller angle, which is great circle minus convergency angle. So when you go to the left hand side, the direction should decrease. So you can see 063 is to the right of rhumb line and rhumb line is to the left of 063 or great circle. Therefore, it is less than 063, which is 060. So this southern hemisphere diagram follows the rule. That means direction here has decreased between great circle and rhumb line, correct? Direction has decreased. So rule is successfully followed in this case. So that means both points Charlie and Delta are situated in what hemisphere? They are situated in southern hemisphere and not in the north hemisphere. Okay, not in the north hemisphere because we have checked both sides. Next, So what is the approximate great circle track from delta to Charlie? So delta to Charlie, what is the approximate track? So let's take a new slide. Very simple. So Rumline at delta was 240. Convergency angle is how much? As you can see, convergency angle is angle between great circle and Rumline. So 63 minus 60 is 3 degree. And now in this case, your great circle will be equal to only this much. This is your convergency angle. So great circle at delta will be equal to Rumline at delta minus convergency angle. So 240 minus 3, which is equal to 237. 237. Okay. So this is how you do the sum. So we found south hemisphere by comparing. Then we normally did this sum to find great circle from delta to Charlie. That is Rumline minus conversion angle. Conversion angle is, we found it over here. Conversion angle is 3 degree. Angle between great circle and Rumline. Okay, so we will stop here and then we will continue in the next lecture, in the next of this convergency lecture from question number 7. Do practice all the questions that we have done till now. Thank you for attending this class. All the best. Do like this lecture if you have liked it. I hope you have understood it also and you have learned something new today. Subscribe to this channel and share this with your friends. Thank you.